So just a quick review. First step, Jonathan, first step.
Subtract 13 from both sides.
Good, subtract 13. Okay. All right, negative 10. Janice? Good. The next step would be you square both sides. But what's wrong with this statement right now?
Uh-oh.
It equals a negative.
Good. A square root equals a negative. Can a square root ever equal a negative?
No, so it's no solution.
It's a no solution. A square root can never equal a negative. Now, can a cubed root equal a negative?
Yeah.
Yes. Okay. No solution there.
Yeah, I forgot about that.
All right. Hey, why don't you take out 10.3, please? Your assignment from Friday, the extra practice.
How was your weekend?
Very good. Thank you. Hey, it's 10.3 extra practice. Is that your student journal?
321, 320.
Here we go.
My lunch is over at 12:45. The class.
Hey, 1 through 3 we did as a class, I believe, or at least we finished them in class. There's our work for those. 16, 121, and 9. Tell your neighbor what you got for 4, 5, and 6, please.
19, 6, and 14.
Yes.
Okay. So we got 19, 6, and 14. All right. Questions on 1 through 6? Go and tell your neighbor what you got on 7, 8, and 9.
2, 4, 4.
All right. 2, 4, and 4. Questions on those 3? Okay, tell your neighbor what you got on 10 through 12.
I got 11. And I got 6.
All right, so we should have 27 halves, 6, and 1/3. Okay, checking out your work. Next page. Page number 13, 14, and 15. Number 13, x equals 125. 14, x equals negative 29. And 15, m equals 2. So cubing each side on those. 16, 17, and 18. We talked about that in class a bit there. So number 16 is negative 3. It's an extraneous solution for that negative 7 there. You have to factor. 17 is no solution. In 18, you get p equals 10 because the negative 1 is extraneous. Remember, extraneous means that you have the extra answer there. Number 19, 20, and 21. R equals 4. Negative 1 extraneous. Number 20 is no solution. An even root cannot equal negative. And number 21, 2, and 5 both work. The last one, number 22. Yes. Because when you take the 16 seconds, you get 2048 over pi r squared, or pi squared. And then when you go 4 seconds, you get 128 over pi squared. So 2048 over pi squared divided by 128 over pi squared is 16.
How do you find out the extraneous solutions? Like, how do you figure out which one's like?
You plug them back in, and if they won't work, so like when I plug negative 1 in, negative 1 minus 1 is negative 2, and then I have a root equaling a negative. That can't be true, so it's extraneous. Okay. When do we get extraneous solutions? How can that happen? Good. When you have to force a root into a problem, or when you have to take a root out of a problem. So when you force like a square or a fourth power, anytime you put an even power into a problem, you could potentially get extraneous solutions. Okay. Any other questions? Your assignment is the online assignment today.